Our planet is in constant motion. It spins on its axis once every 24 hours. A silent and ceaseless dance that has defined life for billions of years. This rotation gives us our cycle of day and night. It shapes the winds in our atmosphere, the currents in our oceans. It is a fundamental force, so deeply woven into the fabric of our world that we rarely pause to consider it. But what if this motion were to suddenly cease? What would happen, in the most realistic and scientific terms, if the Earth simply stopped spinning? This is not a question of fantasy or science fiction. It is a thought experiment grounded in the fundamental laws of physics. To explore this scenario, we must set aside hyperbole and dramatic exaggeration. Our focus will be on a calm, logical progression of cause and effect. We begin with a single impossible event. The Earth's solid body instantly halts its rotation. Everything else that follows is a direct consequence of this initial change. The laws of physics, particularly the conservation of momentum, remain unchanged. Gravity continues to hold everything to the planet's surface, just as it always has. But every object not physically anchored to the Earth's core would retain its momentum, continuing to move at the speed of the planet's former rotation. This essay will serve as a step-by-step guide through the aftermath of such a cataclysmic, yet physically straightforward event. We will journey forward in time, from the very first seconds to the long-term adjustments spanning millennia. Our exploration will cover the immediate and delayed impacts on every major system of our world. We will investigate the violent reaction of the oceans and the atmosphere. We will look at the subtle but significant shifts in physics and gravity. We will consider the profound and devastating consequences for human civilization. And finally, we will map the new climate and the geography of a stationary Earth. It is crucial to state the constraints of our analysis from the outset. This is a purely scientific examination based on established principles of physics. There will be no fictional elements or speculative leaps beyond what the data and models suggest. We are not telling a story of survival, but rather documenting the physical reordering of a planet. By following a clear chronological path, we can build a comprehensive picture of the consequences. Prepare for a journey that begins with unimaginable violence and gradually settles into a strange and unfamiliar new equilibrium, all dictated by the unyielding laws of nature. The moment arrives without warning. The solid sphere of the Earth, from its iron core to its rocky crust, instantaneously ceases its rotation. For a fraction of a second, an observer in space would see the planet's familiar spin simply halt. But on the surface, this event is not one of stillness. It is the beginning of the most violent physical event in the planet's history. The principle at play is inertia. While the solid Earth has stopped, everything on its surface, every building, every tree, every person, every drop of water, has not. At the equator, the Earth's surface rotates at approximately 465 meters per second, or over 1,670 kilometers per hour. This is faster than the speed of sound in air. When the planet stops, everything on or near the equator continues to travel eastward at this incredible velocity. This is not a wind. It is a physical displacement. The ground has stopped, but you have not. The effect is akin to being in a car traveling at supersonic speed that hits an immovable wall. Every object not fused to the planet's bedrock is instantly launched into a catastrophic horizontal trajectory across the now stationary landscape, becoming a projectile in a planet-wide demolition. This effect varies with latitude. The rotational speed of the surface decreases as one moves away from the equator. In cities like London or Berlin, the speed is closer to 1,000 kilometers per hour. In Anchorage, Alaska, it is around 750 kilometers per hour. Only at the geographic poles would the effect be negligible, as the rotational speed there is effectively zero. For the vast majority of the planet's surface, however, the result is the same, a universal, instantaneous and devastating flaying of the surface. Anything not anchored deep within the crust is sheared from its foundation and sent hurtling eastward, disintegrating as it collides with the static terrain. The human body, along with all life and infrastructure, would be subjected to unimaginable forces of acceleration and impact. The initial seconds would not be survivable for anyone or anything in the path of this inertial wave. Structures would be pulverized into dust and debris, which would then join the eastward moving onslaught. The kinetic energy released in these first moments would be immense, equivalent to the detonation of countless nuclear weapons. It is an event of pure mechanical physics, the brutal and unforgiving consequence of the law of conservation of momentum being applied on a planetary scale. The world would be scoured clean in a matter of seconds. Simultaneously with the shearing of the surface, the Earth's atmosphere undergoes an even more dramatic transformation. The vast blanket of air that surrounds our planet also possesses momentum from the Earth's spin. Like the objects on the surface, the atmosphere does not stop with the solid planet. The lower layers of the atmosphere, particularly the troposphere, where our weather occurs, are suddenly set into motion as a global, supersonic wind. This is not a meteorological phenomenon. It is the entire atmosphere being flung eastward across the stationary ground at speeds exceeding 1,600 kilometers per hour at the equator. The immediate result is a cataclysmic pressure wave. The sheer speed of the air moving over the stationary surface would generate friction on an unprecedented scale. This friction would rapidly heat the air to extreme temperatures, creating incandescent shock fronts that would incinerate everything in their path. The atmosphere itself would become a grinding, superheated abrasive, scouring the landscape of any debris that survived the initial inertial impact. Section 3. The Oceans Unleashed. The planet's oceans, vast reservoirs of water holding immense momentum, would react with equal violence. Just as with the atmosphere, the water does not stop when the solid Earth does. The entire mass of the oceans would continue its eastward motion, surging across the stationary seabed. This would trigger the largest and most destructive tsunami imaginable, not as a single wave, but as the entire body of the ocean rising up and washing over the continents. The sheer momentum would drive the water far inland, scouring continents clean of soil, rock, and any remaining debris. The energy of this global surge would be so great that the friction between the moving water and the stationary seabed would generate immense heat. The oceans would literally begin to boil in places. This would inject enormous quantities of water vapor into the already chaotic and superheated atmosphere, further intensifying the violent atmospheric storms. The combination of supersonic winds, boiling, continent-spanning tsunamis would create a hellish environment: steam, pulverized debris, turbulent water. The water would then slosh back, pulled by gravity, creating a series of ever-decreasing but still massive oscillations across the globe. The ocean basins would become giant bathtubs, with water sloshing back and forth for hours or even days to come. Section 4. A slight shift in reality. While the surface is being annihilated by inertial forces, a more subtle but equally fundamental change occurs in the physics of the planet itself. As the Earth spins, it is not a perfect sphere. It bulges at the equator. This is a result of centrifugal force. At the equator, this force reduces the effective pull of gravity by about 0.3%. It is a tiny amount, but it is enough to make you weigh slightly less at the equator than you would at the poles. When the Earth stops spinning, this centrifugal force vanishes instantly. The immediate consequence is a small but universal increase in the effective force of gravity everywhere except at the poles. An object at the equator would suddenly become 0.3% heavier. This disappearance of the equatorial bulge has a profound effect on the oceans. The water that is held in this slight bulge by the Earth's spin is suddenly released. With the centrifugal support gone, gravity takes over completely. The water of the equatorial oceans would begin a slow but inexorable migration towards the poles. The sea level at the equator would begin to fall, while the sea level at the poles would begin to rise. Over the coming hours and days, this will lead to the emergence of a single megacontinent around the Earth's equator and two vast polar oceans. The first seconds, therefore, not only unleash unimaginable kinetic violence, but also trigger the slow gravitational reordering of the entire planet's surface, a quiet but powerful force that will ultimately define the new world. In the first hours after the Earth stops spinning, the initial incandescent violence of the atmosphere begins to evolve. The atmosphere is now turbulent, superheated, and chaotic, far from any state of equilibrium. The familiar patterns of global circulation, the trade winds, the jet streams, the Hadley cells, have been utterly obliterated. The most significant change is the complete disappearance of the Coriolis effect. Without it, air moves more directly, from high pressure to low pressure in straight lines rather than spiraling. As frictional heat dissipates into space, a new driver appears: the permanent day-side-night-side temperature difference. The sun-facing hemisphere bakes, the dark side plunges into deep cold. Hot side air heats, expands and rises, forming low pressure. Cold side air cools, densifies and sinks, forming high pressure. That difference drives a simple, powerful circulation. Air flows directly from the cold night side to the hot day side. Persistent, powerful winds sweep across the globe, a direct consequence of the planet trying to balance its thermal energy. The winds are strongest along the terminator, the twilight zone that separates day from night. Here, the temperature and pressure gradients are at their most extreme, likely generating constant storm-like conditions. While the atmosphere begins to reorganize, the Earth's oceans remain in a state of prolonged turmoil. The water sloshes back and forth across entire oceans, creating a series of colossal standing waves, seiches. A wall of water hundreds of meters high would pull away from a continental shelf, exposing the seafloor for miles, then return hours later with devastating force. The violence grinds down land masses, churning rock, soil, and debris into a thick slurry that contaminates the oceans. The water becomes a murky, sediment-laden soup. In the first days, the planet's oceans continue their slow but dramatic transformation, driven by a fundamental change in gravity. As water drains away from the equatorial regions, a new landmass starts to appear, a continuous belt of territory encircling the planet's waist. This equatorial megacontinent would rise from the ocean. Simultaneously, as water moves towards the poles, the sea level in the high-latitude regions rises catastrophically. The result is the formation of two enormous polar oceans. The familiar arrangement of continents and oceans is completely erased, replaced by a simple, gravitationally stable configuration of one land belt and two polar seas. The dayside becomes a vast, scorching desert where temperatures climb high enough to melt lead in the subsolar point. On the night side, an equally extreme but opposite climate develops. The atmosphere itself begins to freeze. Gases like carbon dioxide and eventually even nitrogen would condense and fall as snow. Between these two extremes lies the terminator, the twilight zone. A place of perpetual storms, driven by the collision of the superheated air from the day side and the frigid air from the night side. This one-way transport of water would mean the day side would become progressively drier over time. while the night side accumulates vast glaciers of ice. For any hypothetical human survivors, the first days would present a series of insurmountable challenges. Now face a planet actively hostile to life. Agriculture is impossible. No topsoil, no reliable water, no stable climate. Stored food supplies are finite. The psychological toll would be absolute. Utter isolation, no hope of communication or rescue. The sun would never move. The stars would never shift. In these first days, survival is not a struggle. It is a slow, inevitable countdown to extinction. Over the long term, the planet's shape would slowly relax into a more perfect sphere. This slow reshaping would likely trigger intense and sustained seismic activity. The Earth's magnetic field would weaken and perhaps disappear entirely. The solar wind would accelerate atmospheric stripping, hastening its transformation into an airless rock. The long-term landscape of the stationary Earth would be one of vast, wind-sculpted dunes on the day side and barren, ice-scoured rock on the night side. Our journey through this thought experiment has taken us from the first violent seconds to the long, silent millennia of a stationary Earth. This step-by-step analysis demonstrates how interconnected our planetary systems are. The rotation of the Earth is not merely a mechanism that gives us our daily cycle. It is the master conductor of a complex symphony that creates a habitable world. It shapes our winds, directs our currents, supports our oceans, and shields us with a magnetic field. To remove it is to silence the music and leave behind only the cold, hard mathematics of physics. Reflecting on this scenario reinforces a profound truth about our existence. We live on a jewel of a world, a planet whose habitability is the result of a delicate and fortuitous balance of countless factors. Our systems, both biological and societal, are exquisitely tuned to the rhythm of this planetary dance, a rhythm we take for granted every single day. This exploration, therefore, is not an exercise in fear, but one of appreciation and understanding. Our spinning world is a place of extraordinary, life-giving motion. And in its ceaseless, silent turning, we find the very foundation of our home, a world that is both alien and utterly inhospitable.